Welcome back to the channel, and today I'm going to solve some engineering problems, complex numbers using the Python. So the first problem here is to find the principal value for negative j raised to j. So let's import your complex math. Then I'll let my z equal to negative 1j and my v equal to 1j. I'll just print the answer. So let's say, so it's z double asterisk of v, and answer here is 4.81. Determine the principal value for 3 plus j4 raised to 1 plus j2. So I'll just change this. So your z will be 3 plus 4j, and my v will be 1 plus j2 or 2j. And my print, so the same because it's still raised to your complex number. So F5, and the answer here is negative 0.42 minus 0.66j. The next number or problem is to find the principal value of the square root or j root, or like 1 over j negative j. So your square root is being used by j instead of the number. So I let my z, or the inside of my j root, is equal to my j or negative 1j, and my v will be 1 all over j or 1j, because when you convert this, it's just negative j raised to 1 over j. And so with this, we'll find the answer. So print your z asterisk of my v, F5, and answer is 0.21 minus 0j, or just 0.21. Next problem is again the square root of a complex number. So I see here we have the 1 plus j2 root of 3 plus j4. So my z will be the inside of the j root, so it's 3 plus j4, all of it's other way around, j4. Then our v will be 1 all over 1 plus 2j. Let me put parentheses. Okay, and our print will be still the same. So the answer here is 1.79 minus 0.88j. We're going to solve or determine the value of your log negative 5. Let our 5 be z is equal to negative 5. Print your cmath.log 10 of your z. This means your logarithm of your negative 5. So let's run. So the answer here is 0.6989 plus 1.36j. Okay, next we are dealing with a ln. So from the previous one, so we just remove the 10 from the log. So let's put here our z equal to 1 plus 2j. Then our v equal to 3 plus 1j. Then we just print the cmath.log of my z times your v, and we just print F5, and answer here is Oh, it's double. So it's 1.95 plus 1.43 J. So next one, we are dealing with another ln, but this time we have 1 minus j square root of 3 raised to 3. So since I cannot use square root in the CMAT, because CMAT only is used only for complex numbers, so I'll just convert this manually. So 1, it's 1 minus j. I'll just type it. So it's 1.732050888. So that's the square root of 3, and I'll just print out your CMAT dot log of your z, then raised to double asterisk raised to 3. So F5, and your answer is negative 1.95 minus 0.36 j. So next we come to evaluate the log of base j, j2. So we have a log in our base. So we just have z equal to your 2j and print CMAT, and we use log CMAT log here. So our x is 2 or z, and our base j, our base, let's say b, is equal to your j. So z comma j. So meaning your z is your x and your base or your b is your j. So that's F5. Oh, j is not defined. Oh, so I'll put 1. Let's run again. And our answer here is 1 minus 0.44 j. Next, our last, it's so the same. We're dealing with another base with a complex numbers. So our base is 1 minus 1j, and the x or the z is 1 plus square root of 3, which is 1.732050808j. So the same format, CMAT log z comma d b f5, and our answer here is negative 0.779 plus 1.23 j. Okay, now we're going on to our next set of problems. This time we're going to deal with our trigo functions. So first one is our sine 0.942 plus j 0.429. So let's import our CMAT. Then let our z equal to 0.942 plus 0.429 j, and let's print the answer. So it is your CMAT dot sine of x or your z equal, or F5, we have here 0.884 plus 0.26 j. Next, this time we have our cos. So change this cos, and our angle is still the same. So we just change this sign into cos. Okay, so F5, your answer here is 0.64 minus 0.35 j. Our lastly is tan. and the same the inside of the tan, so the same the complex number, so we just change here the print into tan. And F5, yeah, the answer here is 0.88 plus 0.89J. Okay, next we're gonna deal with the hyperbolics. So I'll change here, this will be just sine h, and your angle is, let me see, okay, still the same, okay, so we're just gonna change this. So your print CMAT dot, this will be sine of your h, since your complex numbers are still the same from the previous, so we just leave it that way. So F5, so your answer is 0.98, 99 or 98 plus 0.61 J. Next, we're going to have the cos h, and again, so the same, we just change this into cos h, then the answer here is 1.34 plus 0.45 J. Okay, our last one is involving squares. Okay, so just put it down here. So this is your cos raised to 2, 0.9. So this one was interchanged, so this one is 924 plus J 0.429 minus sine h raised to 2 times your 0.94 plus 0.429J. Okay, now we're gonna have our next problem. This time we're dealing with a cos hyperbolic square or raised to square, and also the sine h square raised to square. Next. Okay, next problem, we are dealing with a cos h raised to 2 time your angle is 0.924 plus J 0.429 minus sine h raised to 2 0.942 plus 0.429J. So let's import the CMAT, then we let RZ here equal to our first one, which is 0.924 plus 0.429J, and RV equal to 0.942 plus 0.429J. So we print, then what I did is just I did this 2 times because cos h times cos h is equal to cos h squared. So I'll just put here CMAT dot your cos h cos c. So let's put here your z, then I'll just multiply this by your CMAT cos h cos z. Oh, let me see if I can do this from CMAT import masters. I'll just try. Minus your sine so phi, and times your sine, oh sorry, it should be sine h of your z, sine h z, and sine H, your Z. Oh, this is your V. V. Then you close. I'm just gonna see how this works. And invalid. Oh, sorry. Let's put it here. Okay, next we're gonna have another problem. Okay, this one we're gonna deal with the arc or the inverse. Oh, let's see. Okay, so we have here the inverse or the arc sine of 2 minus j3. So your z is equal to 2 minus 3j. Then we have here, print your a. This is your arc sine. Or your acid of your z. And let's print clear. Then f5. And your answer here is 0.57 minus 1.98j. Next one is your cos, so we just remove this and put your cos. And let's print. And your answer here is 1.00014 plus 1.98j. Next, we have your tan. So it's easy, just change this into tan. Then you print. Then your answer for your tan is 1.4099 minus 0.229j. Lastly, we're gonna deal with your arc sines, your arc or the inverse hyperbolics. And your z is now 1 minus 2j. In this case, we use the same a sine h for this. Okay, so your a sine h, your arc sine h is just 1.469 minus 1.063j. Your cos h is 1.52 minus 1.14j. And lastly, your tan h is just 0.17 minus 1.17j. We gotta do the applications of complex numbers. So the one that we solved last time, so we'll use it in our Python to solve it. So the question is about the resultant forces, the magnitude of the resultant forces. So we have F1. So here F1 equal to 6k. Then your angle of your F1, let's say F1 is equal to of 60, and you have to times it by pi over 180. Next we have your force 2, which is your 2k. Then your angle of your F2 equal to, so it's 45, so 45 times or plus 90, so that's 135 times your pi divided by 180. So your formula for your magnitude of the resultant force is the absolute value of your rec, and just put here F1 and your F1, then plus rec F2, then F2, then we just print out the answer M. So that's F5. So your answer here is 6,797.92 newtons. Next problem, we're now dealing with the, let me see here. Yes, we're dealing here is the distance between the ship to the port. Okay, next we're gonna deal with the distance of the ship from the boat, the ship to the port. So we have here your miles, so it's 3.5. Let's put here your, let's say 8. So this is your 3.5 times your times 22 knots. Okay, then your angle, the angle A is equal to 0 times pi all over 180, and your B equal to 4 times your 22 knots, then your angle B equal to your 90 degrees times pi divided by 180. So the formula for your distance is just your absolute of your rec A, comma, angle A, then we put here plus rec of your B, angle B. Okay, so I just changed the A and B to make it to have a whole number. Okay, now we're gonna print your answer, which is D, and it's F5, and your answer is 116.93. And our last problem is we're dealing with a circuit. Since I have no prior knowledge of the circuit, and I searched in the Google that there is a way that you can solve using a Python, but it's quite difficult. So what I do is I'll use the formula that I find for the V1 and the V2. Okay, based on what I have in my notes. So I'll just excluding the one that has the complex number. So let's have A. My A here is 1 minus J, and I have here A angle of 20, angle of 60. So let's say this is your B. Let's say my B is your 20, and angle B is equal to 60 times pi divided by 180. And what else do I see here? I have here C equal to 3 plus 3J. Let me see here again. Okay, so this is for V1. So I just put here my V1. Let's put my here V1. Okay, now, so this is my V1 equal to 15 minus parenthesis just in case. So 15 minus my A times rec of my B, comma, angle B. Then I'm gonna divide by your C. Okay, so this is my V2. I'm sorry, this is V2. Okay, then in order to find my V1, V1 is just the rec. So my V1 is equal to the rec of my B, angle of B, then plus what's of my answer in my V2. Let's see here. Okay, then let's print this. So print my V2, and let's see, and let's print V1. Let me see, and nope, it's not defined, so I put here 1. Oops, so this is 1, and let me clear this. So let's see if this works. Nope, rec doesn't define. Rec rectangular. Yeah. So this is wrong again. So this is rec. Okay, then let's play. Okay. So my answer here is negative 3.27 plus 0.833J. This is for my V1 or V2. So, and my V1 is 72 plus 18.15J. And this is my answers for the applications for complex numbers. Thank you so much for watching the video. I learned about the Python more. I think Python's useful when it comes to solving complex numbers. Because when you do it manually, sometimes you might get wrong answers. Even though you have a calculator, sometimes I will get wrong answers. Just a nick of time, it's ready after quiz number 1, and I learned that my answers are really wrong, and I hope I can use Python to recheck my answers if they are correct, and if not, I have to redo it again. Thank you so much, and see you in the next video.